This lesson is about complex fractions. Just when you think you've had enough of fractions, now we're going to put a fraction that has fractions in the numerator and or the denominator. So fractions within fractions. Our directions are going to be to simplify the following fraction. We're going to first start out with single fractions. We're just going to change the division to multiplication and reduce, because this sign right here means to divide. So really what this problem is 21x to the fourth over 8y divided by 7x cubed over 16y squared. Well, just as we've learned back in elementary school, if you have division of fractions, you want to change that to multiplication. So we're going to change our division to multiplication. So we're going to have 21x to the fourth over 8y times 16y squared over 7x cubed. Now we're going to reduce. Let's see what we have. I have a 21 and I have a 7. 7 goes into 21 3 times. I also have an 8 and a 16. So 8 goes into 16 2 times, and 8 goes into 8 1, and I should have put a 1 there. So we're just reducing. I like to do my numbers first. Now I'm going to do the letters. So notice, let's see, I have an x to the fourth and an x cubed. Those are the same base, so I can keep the base and subtract the exponents. So that's going to leave me just an x to the first power on top. Then I have y's, so I have the same base. I'm going to subtract the exponent, keep the base, and subtract the exponents, and that would be a y to the first power. And of course we don't write that first power, but just to emphasize that we keep the base and subtract those exponents. Now let's do our multiplication. And notice I really don't have anything left on the bottom except 1, and on top I have 3 times 2, which is 6, and x times y is xy. So this is not any different than multiplying rational expressions, which we've done previously. Let's look at the second example. Again, I have a single fraction divided by a single fraction, but I don't have monomials anymore. I've got trinomials and binomials. So let's go ahead and rewrite this as division. So we have x squared minus 5x plus 6 over 10x plus 5. And that's going to be divided by 4 minus x squared over 6x plus 3. So now we're just dividing rational expressions. And as you recall, we need to factor before we can reduce. So how do we factor that trinomial? Pretty easy. It has a coefficient of 1, so we need -2 and -3. How do we factor that binomial? GCF of a 5. And now I'm going to change that to multiplication. So I'm going to multiply by the reciprocal. So this is going to go on the bottom, but I'm going to factor that. And notice that is the difference of two squares, but the 2's come first. So 2 times 2 is that 4, and x times x is x squared, and I need a positive and a negative. Hopefully this is not confusing you. I've changed the division to multiplication, so I had to take the reciprocal here. So the numerator has come to the denominator, and I have factored. Now this has got to go to the top, and I'm going to factor that. Has a GCF of a 3. Now I'm ready to start reducing any common factors. Let's see, do you see anything we have? Oh yeah, 2x plus 1 and 2x plus 1. Anything else? Hopefully you're noticing that x minus 2 and 2 minus x are opposites. We've talked a lot about that. They are opposites. So when we reduce opposites, what's left? A factor of -1. So now I think we have reduced everything we could. So let's not lose that -1. So -1 times 3 is -3. And then I have an x minus 3 left on top. On the bottom I have a 5 and a 2 plus x. There you go. Again, just a review of multiplying and dividing rational expressions. So you say, how could this get harder? Well, we're going to leave single fractions and we're going to move on to multiple fractions. So now we have not just a single fraction divided by a single fraction, but count them. I have 1, 2, 3 fractions within one big fraction. So our process is going to be a little bit different. We need to find the least common denominator of all the fractions. We know how to do that. Remember, we have to write down one of every kind of factor. So we notice we have a 5, an x, and a y, and then we need to raise it to the highest power on each factor, so I need that x cubed. So that's my least common denominator of all 3 fractions. Now I'm going to multiply every term by that least common denominator. I need to write this where I have a little bit more room. So I'm going to space it out a little bit. So I have 3 over x minus 1 over y divided by 6 over 5x cubed y. And I want to multiply every term by this least common denominator. So I have 5x cubed y, and that's over 1. Now, why are we doing this? First of all, we're multiplying everything by the same, so that keeps it equal, but it's going to get rid of some of these fractions. Right, so now I need to reduce all that I've created. So let's see, I have that x reduces with that, and I'd have x squared. So I know that's a little messy. So I have 3, nope, not 3. What did I miss? 3 times that 5. So that's 15 x squared y. And notice, now that's just over 1. So I've gotten rid of that fraction. Minus, here, let's see, the y's reduce, and I'm left with minus 5x cubed. On the bottom, all of that goes away, and I'm just left with 6. So I've gone from 3 fractions within a fraction to just one big fraction. And I have to reduce more. How could I reduce that? Well, remember, we always have to factor. So what am I looking for in the top? A GCF of 5x squared. And I believe that would leave a y minus x on top of 6. Can I reduce that? No, nothing in common. So I could have stopped here. That would be correct. Or I could leave that as my final answer. But notice, what did we accomplish when we multiplied everything by that LCD? We went from 3 fractions to just one big fraction. Makes it a little bit easier. So on this problem, we don't have 3 fractions, we have 4 fractions. So I need to find the LCD of all of them. Right? So I'm going to write down my LCD. Remember, it's one of every kind of factor. Well, let's look at the numbers first. 2, 7, and 14. What number do they all divide into? 14. And then I see an x and I see a y. I think that takes care of all my factors raised to the highest power, so that's my least common denominator. And I'm going to multiply every term by that 14xy. So again, I'm going to create myself a little bit more room. Right? Remember, I'm going to multiply by this, and that's over 1. And I'm doing this to go from 4 fractions to just one fraction. So let's see, what have I accomplished? I can reduce the x's, and I'm left with 14y. Here, 2 goes into 14 7 times, and so I have minus 7xy. And all of those denominators are now 1. On here, 7 goes into 14 2 times, and the x's reduce, so I have 5 times 2, which is 10. I've got my y left. Minus, all that reduces, and I just have 5. Am I done? Well, I don't know. Can I reduce that? Well, I see some GCF, so I'm just going to factor and see if I can maybe reduce. So what do I have here? I have a GCF of a 7y, and that would leave me 2 minus x. On the bottom I have a GCF of 5, and that would leave me 2y minus 1. Even though I could factor it, there's no common factors. So again, I could have left this as my answer, but I really had to check it out, so that's also a correct answer. So we've had a problem with 3 fractions within the fraction, 4 fractions within the fraction, and now look at this. We have got 6 things because that 2 and 4, really you could count them as fractions as well. We're going to go through the same process. Find the LCD of all 6 things. Well, the good news is that that's not bad. I see a 3 and I see an x, and what's the highest power on x? X squared. So that's my LCD of all 6 things. So again, I'm going to space that out, and I'm going to multiply everything by this LCD of 3x squared. And I'm going to reduce and go from 6 fractions to just one big fraction. Now notice on this first one, there's nothing to cancel out. I just have 1's on the bottom, so I just need to multiply that together, and I'm going to get 6x squared. On the next one, the 3's cancel and one of the x's cancel, so I have minus 7x left. On the last one, all of that goes away, and I just have minus 10. Again, on this next one, I have 1, so I just need to multiply that together, and I get 12x squared. Here, same thing, leaves me an x, so I have minus 8x. On the last one, be careful, only the x squares cancel, so I've still got that 3, and 3 times 5 is 15. So again, I've gone from 6 fractions to one big fraction. I can't just start reducing here. I have trinomials. I have to factor, and they may or may not factor, but let's see if they do. These are not fun trinomials, so let's just start trying something. Let's see, for 6 I'm going to try 2 and 3, and for 10 I'm going to try 2 and 5. Can't put the 2 at the 2, so let's try that. Checking my middle term, that's going to be 15, that's going to be 4. Oh, that doesn't give me 7. But I don't think the 10 and 1 is going to work. That's just too big. So I'm going to erase and try again. Trinomials, try again. Right, so instead of 2 and 3, let's try 6 and 1. But I'm going to stick with my 2 and 5. Can't put the 2 at the 6, so let's try that. That's 5x, that's 12. If I make the 12 negative and the 5 positive, I get my negative 7. Alright, I'm good with that. Now, 15. I know that's either 3 and 5 or 1 and 15. But since I have that 5 up there, I'm going to try the 5 here and the 3 there. And on the 12, I have 1 and 12, 3 and 4, 6 and 2. But again, since I have the 6x plus 5, let's try that. So let's try the 6 there and the 2 there. And I need to get my signs to have a negative 15. That needs to be negative. Now let's see if we can get that negative 8x. So let's see, that's going to be 10x. 6 times negative 3 is negative 18x. Yeah. Alright, that factors. So notice, even though not easy factoring, I used one answer to help me factor the other part. So now I can reduce my common factor of 6x plus 5, and that's my final answer. Wow, after that last one, this doesn't look too bad. I have 4 terms, maybe not 4 fractions, but I have 1, 2, and really 3, 4. So let's do that LCD. So the 1's and an x and a y. That one's pretty easy. So I need to multiply each of these by xy. So again, I'm just going to kind of write it out with a little bit more space. Remember, those are over 1. So I multiply each of these by my LCD of xy. And then I want to reduce. So I have 2y plus x. Nothing cancels there, so that's x squared y plus nothing cancels there. That's 3xy. Wow, that was pretty easy. But man, looks it looks like I could reduce because of all those x's and y's. But before you reduce binomials, you must factor. I cannot factor 2y plus x. There's no GCF. Here, they have an x and a y in common. Again, nothing factors. So this is an okay answer. This is an acceptable answer. Let's look at this final example. Count them. We have 1, 2, 3 terms. But we've got this looking fraction. That's quite different. So what's my LCD? Well, I know it has to have that 3 because that's one factor. 3 plus h is a factor. So I need 3 plus h. And then 1 multiplied by 1. I still have that. So that's my LCD, the 3 and the 3 plus h. So I'm going to put these in parentheses so I can remind myself that those are factors and I might need to distribute. So again, multiplying each term by my LCD. Put that over 1 if that helps you. And now I want to reduce. Notice those reduce out, those reduce out. So what do I have left here? I have that 3, and I'm going to go ahead and distribute. So that's 15 plus 3h minus, I'm going to distribute there as well. So I have minus 15 minus 5h. I'm distributing a negative 5. That's the tricky part. Remember, anytime you have negatives, those red flags need to go up. Here, nothing cancels. I just need to really distribute. But you know, I think I'll just write this as 3h times 3 plus h, and maybe distribute on the next step. Let's collect like terms on top. 15 minus 15. Hey, that's 0. 3h minus 5h. What's that? That's negative 2h. Well, I'm kind of glad I didn't distribute. Since this is already factored, everything's multiplied together. Do you see a common factor I can reduce? Hope so. That h is a common factor. So my final answer is negative 2 over 3 times 3 plus h. The reason why I did this example is because this LCD is different. It involves a binomial, which you have seen as LCDs on previous lessons about adding and subtracting rational expressions. So just to recap, if you have single fractions, you're just going to change the division to multiplication and reduce. But if you have multiple fractions, you want to find the LCD of all the fractions, multiply every term by that LCD. That creates you one big fraction, and then in order to reduce, you're going to need to factor and cancel out common factors.